all participants. Welcome to the session 10 of online FDP on AI in cloud computing, theory, practice and applications. Now the session will be handled by Dr. Satyajit Nayak. So let me introduce her to you. Dr. Satyajit Nayak is currently working as System Architect, DSW, Comfort Driving Assistant Product Group, Valeo, India. He worked as Technical Architect in Advanced Driving Assistant System in Research and Development Wing of Tech Mahindra, Bengaluru, India. Dr. Nayak worked as a lead technical analyst in Humasys Technologies Private Limited, Kolkata. He also worked as assistant professor at Gandhi Institute of Technology, Bhubaneswar, Odisha. He received PhD degree from Indian Institute of Technology, Kharagpur, India. He has 7+ years of teaching and research experience and 8+ years of industrial R&D practice and product development. He received 10+ awards from IEEE, STPI, MOE, MEITY, CSI and others. He is also an IEEE senior member. He has published 16+ papers in reputed journals and conferences. He published 15 utility patents, 1 design patent, and 7 copyright granted in the field of invention in ADAS, HMI, AICV, AIML, and BME. His current research interests include computer vision, HDI, graph neural network, and autonomous system. He delivered 15+ invited talks, FDP, and guest lectures. He acted as a reviewer in many reputed journals of IEEE, ACM, elsewhere, and Springer. Now, sir will tell about ADAS, Automatic Driving Assistance System.
Thank you, madam. Good evening to all. First of all, before I start the session, I would like to extend my sincere thanks Department of Computer Science, NIT Warangal, organizing such a beautiful the FDP on AI in cloud computing, theory, practice, and applications. I'm privileged and honored to be here as a keynote speaker. Before I start my session, I would like to extend the sincere gratitude to inviting me as a the resource person from the coordinator side, Professor Dr. Priyanka Chawla, Professor Dr. Sanjay Kumar Panda in this session, and I hope there are a good number of participants, almost 22 participants. Shall I share a screen, ma'am? Is it okay?
Yes, sir. You can share the screen.
Okay. Please confirm it is visible.
Yes, sir. It is visible, sir.
Thank you. Today's session, I prepared for the particular topic, the impact of AI in computation and perception for autonomous driving system. Before I start this session outlook, I would like to know regarding the participants, the background, and their exposure related to the particular topic. It would be very nice that if you can share your exposure, share experience on this particular area. If someone, please. I request all participants, if anyone come forward and at least share your experience, your the prior knowledge related to the particular topic, ADAS, maybe not only ADAS, maybe any AI perception system. Okay. Okay, so before I start this discussion forward, I would like to introduce our organization. Myself, Satyajit Nayak. I am working as a system architect at Valeo is a tech company. It is an automobile supplier across the globe, and it is a 100 years company so far. And if you look at these our verticals, we are the players of mobility and digital, electrification, and autonomous and connected cars. And we have so far the particular R&D kind of centers across 33 countries, 184 production sites, and 55 research and development centers, and 15 distribution platforms. And so far it is the record of the 2023. So employees, headcount, you can say 1,11,600 so far, roughly. And there are the 4 balanced and coherent business group. We are, our company taking care. One is the visibility and system, then comfort driving assistant, thermal system, and power system. And my exposure or my kind of a business entity, I involve comfort driving assistant, where there are different verticals: driving assistant, telematics, and interior controls. And before I start this discussion, again come forward, I'd be happy to know that based on the topic outline, that there are 2 extreme directions. You can say machine computing or intelligence. Based on that, what is your you can say knowledge, or you can say your view, if you compare the automation with artificial intelligence? I would like to know from the participant side. Could you please mention some points if you have the prior exposure on that area? How automation is relevant to AI, or you can say automation versus AI? If anyone, please. Okay. Let me, coming to the session outline, is very high level. I will introduce that AI at glance. Then we can discuss that AI at computation, how AI, playing a very pivotal aspect in computation nowadays. What is the impact of AI in ADAS system? Again, you can come to that detection of AI perception, and then some use cases related to ADAS in how AI is impacting in that particular exposures. And then I would like to know from the audience that what is the future of AI? After all that discussions will come forward. The first talk will be regarding that AI at a glance. Everybody knows what is AI. To explain the definition part of AI. So I have prepared for that very, again you can say some coherent interlink between this AI past, present, and future. If you look this diagram, just kind of the snapshot I have taken from the internet. If you look that, what is AI, and there is a question why AI, then how AI is going to play a vital important role in our computation and perception. That's the entire talk about. So if you look that what is AI, of course it is a kind of the one problem solving. May I switch off my camera, ma'am? Is it okay? There's some less bandwidth in my end. Okay. So if you look that what is AI in current scenario, so solve problems using computers or make automated decisions. And as I mentioned in the previous slide, automation versus artificial intelligence, how automation is playing a vital role in place of your to develop a AI system. So you can say in general, automation is about setting up system to follow a set of predefined rules. However, artificial intelligence is about setting up the method to make the system to take its own decisions. And if you look at this ADAS system, from ADAS domain perspective, automated system responsible for collate the sensor fleet data. And again, you can say that AI methods or process to make interpretations on those data. That is all about this. You can say the automation, how automation differ from AI, or you can say automation versus AI. So if you look at what is AI, of course, it is AI referred to be the replication of human intelligence processed by machine, which enables the system or machine to learn from a pattern, reason, and perform tasks automatically. If you look that particular aspect, that is, you can say AI all about nowadays. And the purpose of AI, of course, this is one diagram I have given in the left hand side, right hand side, one particular in the flow. If you look at why AI, the purpose of AI, of course, system is to learn the experience and the leverage computational technique to analyze the problem. If you look at the left hand side diagram, it is obvious it's kind of a the one snap I have taken from internet. That is, if you look this, there are different type of, this is a one car, the snap taken inside the car cabin windshield. Look the car surrounding this car, the environment around the car. You can say there are a couple of things, maybe on another car, another vehicle, maybe the road signal, maybe the traffic system, maybe the pedestrian, maybe the, you can say some particular the lane, road lane, or you can say some different static objects. So you can say more or less two type of object, two type of agent or object, you can say, can come around your vehicle. Your vehicle means, you can say, the ADAS vehicle. If it is ADAS vehicle, we are saying it's an ego vehicle, right? Which is AI enabled ego vehicle. And to perceive that problem, to perceive the surround, which is in terms of two type of object can come to picture. One is your static object, and there is your dynamic object, or you can say dynamic agents. So here, if you look, there are two type of thing. One is a path hole. This is the path hole on the road itself, and then there is the other car, which again is a dynamic entity. Then some pedestrians, or you can say the, or you can say that vulnerable road users, right? This is also one dynamic agent, and different traffic system, road lane, they are also kind of static objects. So the entire environment around this ADAS ego vehicle divided into two segments. One is your dynamic object, another is your static object. So our action, how the AI enabled ego vehicle can take a decision, right? And by looking there, the moment can plan the path. So we can say the trajectory path planning based upon the perception, and the ego vehicle can take decision. That is the most important part in this picture, where AI is coming to picture. And if you look at this, the purpose of AI, more or less, it is only can say problem solving. So problem solving, the problem might be a complex problem, the problem might be a simple problem. Of course, similar fashion, we can say the solution might be a simple solution, or it might be a complex solution. If you look at this, the statement I mentioned over here, AI is being used to make decisions about your comfort driving for better safety. Why it is going to, why we are bringing this AI technology into the ADAS system? It is really required to bring this AI. We are driving our cars very comfortably, right? So why again that AI coming to picture in this ADAS ego vehicle? How the AI computation system, AI perception system playing very pivotal role in this the particular system of ADAS. Why it is going to be important to enable the AI? If you look that, nowadays, considering your safety system. Suppose, let's say, someone going to purchase a new vehicle or new car. Nowadays, we are first asking the question to the vendor, to the supplier. We're asking how far the safety is enabled in this car? Maybe a car, maybe a two-wheeler, any kind of vehicle you are going to purchase from the market. We're asking to the vendor that whether this car having the safety features, what type of safety ratings you have, how they can going to to deliver the car to the customers with particular safety features or safety ratings based on these their system, based on the particular perception, based on the computation, based on the decision. They are going to say, yes, our car is more safety as compared to other vendors because our car is AI enabled in terms of perception, decision, computation. So this is all about this kind of why AI coming to picture nowadays in ADAS. Then if different stories will come, how to solve the problem, what type of problem nowadays we are facing in ADAS itself. Then what type of the solutions we can pitch to the particular problem. They're different story. But coming to the entire discussion, forward to this session, I thought to bring this the concept of why AI in ADAS. Okay, it is a very traditional way that people are saying nowadays it is strong versus weak AI. People are saying that what is strong AI, what is weak AI. I thought give some kind of glance on that topic of strong versus weak AI. If you look this strong AI, I can say having cognitive ability similar to human level of intelligence, right? This is called a strong AI, or you can say the strong concept of AI. If it is weak AI, not having cognitive ability, right? So, but if you take the decisions which is good to adopt in these the current scenarios. So if you look at these statements, this is not what we have today. There is no evidence that we are close to strong AI. There is no evidence right now that we are close to strong AI. But we have the evidence towards the weak AI. As I mentioned, weak AI means having cognitive ability. That means we can say not having cognitive ability. We have the particular pattern to train a machine or through an algorithm. That machine can take a decision on behalf of the human, or you can say the particular machine interpretation can be happen through a AI algorithm or AI system. But do we have such kind of the patterns? Can we train a machine? Can we train a system which will be acting as a human being, having a similar human level of intelligence? Can we prove it right now? If so, you can say it's a strong AI. That's what I'm saying. There is no evidence that we are close to the strong AI in current days, in current scenario, in current scenarios. But all we are moving towards the weak AI, or you can say weak pattern-based artificial intelligence. Coming to the same thing again, that the Turing test, because I thought give some kind of some background knowledge on that AI in Turing test. Turing test is to check the machine or system ability of computation. As our topic mentioned that the impact of AI in computation and perception in ADAS system, I thought to bring some the background behind this computation. So you can say that the Turing test involves normally in a human judge engaging in this picture. You can say a human judge engaging in natural language conversation between human and machine without knowing the context details. In today's AI system have made significant strides in simulating human-like behavior in certain contexts, especially when we are facing the particular complexities of general conversation. And if you look at this, the requirement, of course, the requirement is very clear that there are different kind of the domain adaptability. maybe natural language processing, knowledge representation, automated reasoning, machine learning, vision perception system. There are different the particular requirements. Based on that, you can say the computation is coming to a shape. If you coming to the next part, the Turing test and the Turing machine, as mentioned very clearly, this is from the from particular internet source I copied. The Turing machine is a mathematical model of a physical computation or computing device. So normally you can say it is a kind of one mathematical model to to compute any particular problem. So any given problem for which there is a Turing machine that computers, the solution is clearly computable by a physical machine. So if you look at the Turing test, this is all about this that human beings are intelligent, and to be you can say how it is called intelligent. A machine must produce responses that are indistinguishable from those who are a human, right? This is a kind of Alan Turing's the theorem, Alan Turing theorem, can say. So we know this all about this kind of the theory aspect. Coming to this the shape of AI. Nowadays everybody is saying that AI is very fancy term. Everywhere you can go nowadays, even the students from standard 5, they are also saying they also have some kind of context in their syllabus, in curriculum that they are covering in the schools. Some of the they are saying the shape of AI, right? So if you look at this, AI is a wider bracket, and then subset of the AI, it is a machine learning. Again, subset of machine learning is your deep learning. Again, there are different techniques coming to the picture. So already in that market, I have not yet captured these things, all things in particular, the figure. But overall, I can say that how the interlink between that AI, ML, and DL. So what is AI? Again, that algorithm to mimic human intelligence with some logic, or you can say the rules, or you can say the pattern may not be trained through some data. And of course, machine learning, it is a kind of the computer or the computing system, the ability of automatically learn and provide from experience without being explicitly programmed. This again is a kind of theoretical definition of book. Sorry. And we can say deep learning. Again, the subset of machine learning is deep learning. So use multiple layers to progressively extract higher level features from the raw input. There are different kind of input patterns. Maybe we can say the image, video, text, then speech, or different types of the particular input by nature, with the features and classifications both learn from the data. This is all about definitions of deep learning. Coming to these AI techniques, I thought not to explain these all techniques, but very high level I should have to give a glance on that. Rules and the logic. There are different kind of AI techniques. I categorize into 3. One is the rules and logic based, another is your pattern based, another is a hybrid based. If it is a rule and logic based, you can say the expert system. Then representing process or system using the logical rules, then top-down rules, and then computers reasons about those rules and can be used to automate the process. So then you can say machine learning pattern. Maybe it is the kind of algorithm find a pattern in data and then infer rules for their own, or maybe they learn from data and improve the over time. Similarly, also machine learning is an advance in AI today. So these are the particular pattern-based techniques people are following in a everyday practice, right? And for the hybrid pattern, you can say machine learning and rule-based hybrids, and then human intelligence plus AI hybrids. So there is no, you cannot say that the techniques are fixed. We can say the particular techniques are not at all fixed every time or every domain or every problem solving approach. You can go beyond that a particular the techniques. It may be dependent upon your problem, it may be dependent upon your solution, it may be dependent upon your the resource, it may be dependent upon your requirement, it may be dependent upon your domain. So there are a lot of things to in coming to picture whenever taking decisions which AI technique to be applicable to solve the problem. So we cannot say it it's a kind of single go. We cannot say single go. We cannot say decisions taken by this human that okay, this is the problem, I should go with this particular approach. We cannot say, because there are several dependent things to solve the particular problem at that moment. Again, that machine computing, if you look at the machine computing or intelligence, again I mentioned that automation, how automation is going to carry forward AI based system, right? If you look at this entire slide, the important part is over here, that human versus machine. As I mentioned in the previous slides, the human having the cognitive reasoning intelligence, the consciousness of a human being is the cognitive part, which is missing in the AI system, right? So this is the kind of the only reason that we can say that AI may not overcome this human being, because of this cognitive aspect is missing. The intelligent thinking capacity is missing in that particular AI system, AI based system. But it is very helpful where human being cannot consider at a time in the human being's intelligence, or this particular time period, human cannot think these calculation, these expectation, these perception, or you can say these cannot take decisions based on these the human intelligence at a stress. So but a machine which is trained by this particular pattern, which can take decision, is very much better than a human being in that particular time period where human cannot. How it is happen? How it is is very easy for a AI based system to take decisions automatically, because data driven world, the data science is very important. Based on the data, based on the pattern, based on this on a particular the training pattern, the model or the AI based system is much better than, can take decisions much better, much safer, much accurately than the human being. And if you look at this kind of the can say the hierarchy, that AI, again, that is a machine learning and or we can say pattern recognition, then data mining, then agent robotics, then autonomous system, and because if you look at the autonomous system, and this is an up hierarchy and also down hierarchy. In up hierarchy, you can look at the traditional ways, and the down hierarchy, that is a kind of more analytical things are required, maybe deep learning, data science, quantum inspired computation. So these things are not a you can say never ending things. We cannot say that now the market is already saturated. We cannot say like that. So autonomous system may be a vital kind of domain in coming days, based on this the involvement of the deep learning, then data science, you can say the data engineering, and the quantum inspired computation. Same thing again in the slide, that AI and machine learning, introducing the cognitive sense, which is called reasoning, or you can say the intelligence into machines. So whenever you're giving a input to a AI system, of course the AI system trained with a particular pattern, particular the scenario, or that you can say the data, or you can say the on particular this the sequence of your pattern. But of course that give you the with this experience, that AI system can give the output. But one thing is missing in that aspect, cognitive sense, which is called the reasoning. We are trying a lot right now to develop such kind of things, but so far I don't know but whatever my knowledge is concerned, that I don't know how it is success so far. But still we are struggling. We are trying to to make this system as a cognitive based system, cognitive based AI system. This is a kind of the current hot the research in everywhere across globe. We are doing that, how the cognitive part is involved in AI system. Again, that deep learning, that two things I have given over here. One is your image, another is your that language. The deep learning achieved a human performance level in the cognitive task of language. There are a number of examples. If you look at these Tesla automation cars, photo tagging system at Facebook, virtual assistant such as Siri or Cortana, chatbot, and so then object recognition, cameras, etc. There are the particular applications of AI, which is the deep learning based human performance level in these tasks. So coming to this landscape of AI, if you look at the landscape of AI, that is very, very again simple. I have mentioned that how this the descriptive system, the predictive system, and the perspective system. The goal is here to provide actionable insights. There are different kind of AI landscape. You can think, if you look at this, I mentioned that chatbot, then personal assistant, automated insight, autopilot by Tesla, then deep dream, then AlphaGo. There are different you cannot say this is a one kind of one restricted landscape. This is an extended landscape. Anywhere you can apply nowadays AI, right? So we can say or you can say kind of two type of sophistication. One may be a narrow AI, one may be a deep AI. So if it is a deep AI, again you can say continuously learning. If it is a narrow AI, you can say the particular basic task, the basic things to be captured in this narrow AI. So if you look at this AI landscape, as I mentioned clearly, descriptive means what? Descriptive means that is called descriptive analytics, where historical data is analyzed to understand past event. Then what is called the predictive analytics? That means where future outcomes are forecasted based on the data patterns. Obvious thing, whenever it is a kind of your future aspect required, and you need to forecast some of the future based on your data pattern. What is the perspective analytics? That means you can say where a actionable insights and recommendations are provided to guide decisions making and achieve desired outcomes. This is the kind of your the perspective analytics. So if you look at this AI landscape, obvious any kind of extensions you may go, or you can pitch this AI into different aspects, the different domain, different business, different the problem, different the product, different process, different system, and different society. So you can put it different directions of AI. That is called AI landscape. But anything, the objective is clear, that to provide actionable insights, and of course the actionable insights will be restricted by these three analytics. Maybe a descriptive analytics, maybe a predictive analysis, maybe a perspective analytics. Of course, you can utilize these landscape. We can utilize these AI techniques for such a the system where we require descriptive, predictive, and perspective analytics. And next we will come towards this AI and computation. Though our topic title was that is the impact of AI in computation and perception in ADAS system. So again, I'm coming to this AI and computation. If you look at this, very basic, AI concept. Of course, as I mentioned that machine learning and deep learning. Machine learning is the subset of AI. Again, deep learning is the subset of machine learning. Again, there are so many number of you can say the techniques. So many number of the we can say the versions of machine learning. Sorry, deep learning may come to picture, but I have not captured these all in these discussions. I just restricted myself to put this some particular boundary, so you can cover these things in our discussion today. If you look at this hierarchy of machine learning, normally it is very clear to all of us that machine learning is kind of very famous the technique, not that today's technique. It is so long back we use these machine learning techniques like supervised learning, unsupervised learning, and reinforcement learning. If you look that this supervised learning. You know, to explain that part, what is supervised, what is unsupervised. I hope these all audience present over here, they know these, you know, the basic things, basic definitions of supervised, unsupervised, and reinforcement learning. But rather to, you know, go to the definition part, I just try to touch this, you know, the a particular category of algorithms of machine learning, which is comes under supervised learning. Maybe you can say this kind of two types of supervised learning algorithms you can, you know, realize. One is a classification, and there is your regression. Similarly, for unsupervised learning, you know, we are trying to focus three different directions. One, the clustering problem, which may be a hard clustering, maybe a sub clustering. If you look at the hard clustering, of course, in hard clustering, it is a kind of your k-mean clustering. In this approach, the data points are exclusively assigned to one cluster, where the sub-clustering, that means you can say the Gaussian mixed model, where the data points are assigned to probabilistically to a multiple cluster. So this is the difference between that hard and soft clustering. And if you look at this density estimation, is again, this is very, you know, we can say straightforward parametric, non-parametric density estimation, and then dimensionality reduction. So there are different techniques. You can say PCA, number of things are there in that particular, you know, the variety of unsupervised machine learning techniques. And then for reinforcement learning, this is either it is a positive reinforcement learning or negative reinforcement learning. That means learning from the mistake. So this is called positive, or you know, maybe called sometimes called negative. So I just categorize these, you know, the particular AI, ML, or sorry, you can machine learning the algorithm techniques into different varieties, different category. So inside one category, there are a couple of algorithms already people are using nowadays for every domain, every problem. No need to explain these all, you know, one by one. Coming to these feature and instances, if you look at the any particular machine learning algorithm or any, you know, deep learning algorithm, the very important part is called the feature. And as I mentioned here, from the particular, you know, in the internet source, I copied that part. On basis by which a machine learning algorithm make a decision, which is called a feature, or you can say in a different way, a measurable property of the data, and also called attribute. And if you look at this same thing, you know, before coming to the development pipeline of these machine learning algorithms, the features are very, very important to consider. Without the features, we cannot, you know, think to develop the machine learning algorithm, the machine learning system. Similarly, what is instance? If you look at the instance, that instances can be specific person together with his you know, attributes, or you can say an instance is a sample in the data, or you can say instance is described by a number of attributes or feature, and instance may be labeled or unlabeled. So these are the instances in the features. Let's say, giving the example of this particular scenario in ADAS storm. Let's say you are going to develop a perception algorithm, or you can say the deep learning perception algorithm or AI perception algorithm, which is going to detect the road objects when your ego vehicle is moving. Just like, you know, only for object detection. Let's say consider object detection. And of course, there are, you know, whenever the model is trained, you have certain kind of images or videos where there are number of features you are, you know, you are planning to train a particular algorithm, maybe we can say model. Based on that, what is instance, what is features? Suppose the features we are considering, where you can say that might be if it is your geometrical perception. Now, of course, there is some geometrical features. If it is your, you know, you can say the deep learning perception, of course, that is you know, kind of your image or video you need to consider for this, you know, training process, model development process. But instances means, suppose as example, giving a some other example, suppose there is you are going to detect the only vehicle light. Let's say your focus is to detect the vehicle light. In the vehicle light, you know, you develop an algorithm using the machine learning or deep learning. only to detect the vehicle light type. Suppose again you're considering there are vehicle light type, maybe your the couple light, or you can say you can say the front couple light, back couple light, then front single light, back single light, then street light, then traffic light. Suppose these are your classes. You have planned to develop a model based on your the features on this particular class. So what is the instance? Before you train the model, we need to do some data distribution access or data distribution part. Why? Because to ensure that how many instances are there per class. Suppose let's say you have a certain amount of data set, let's say 15 GB data set, or let's say particular you can say 300k images, or 300k you can say 500k images, or some particular features. And out of these images, how many instances per class? There are 5 classes: front light, back light, single back light, then single front light, then also street light, suppose. And you have to find how many instances per class. Why it is required to do the distribution? Because you ensure that the model will not be overfit during training, so that there is some constant loss will be there. And to avoid that particular, these kind of overfitting scenarios across this model training, we need to find distribution where you can check the instances present in that feature per class. This is called a kind of specific requirement for the instances to find out. Okay, and coming to this feature selection and extraction. So if you look at this feature selection involves selecting a subject of the available feature said to be used in learning and classifications. This again, I'm saying this is the kind of that your definition. If you look at this feature selection and feature extraction, how it is not how it is different from each other. Whenever you coming to feature selection, that is called irrelevant or partially relevant features can negatively impact model performance. But feature extraction means it is relevant to dimensionality reduction. And here the objective of feature selection is to remove the irrelevant feature, correlated feature. And here the objective of the feature extraction means reducing the overfitting, improvement the accuracy, and reduce the training time. So these are the particular very exact requirement. This is the based upon your the technique of feature selection and feature extraction process. If you look at this again, the validation model. So let's say model is trained. What is what technique to apply, what algorithm to apply, what feature to consider, how many instances to check, how many the particular the technique you applied for feature selection and feature extraction. Let's say model is trained. How you are going to and why you are going to do the model validation. Before model testing, you need to do some model validation, because if you do your model validation, your model can be performed very accurately, very perfectly, with different kind of data pattern, different type of the particular features when it is well trained. And this is the only reason that to check that model is well, how much it is fit to do the particular perception or do the particular the performance with the other type of data. Because let's say the data is X, you train the model. I'm going to check with your data is X bar or Y data set. Then of course you need to, if the model is not well validated, then there is no guarantee that the model will give you the good result, because you have trained a particular data pattern and you expect to run the model again with different data pattern. So before that different data pattern to run in your model, if the model is well validated, then you can say the one particular guarantee that yes, of course, model can be perform better in that scenarios where the data is not used for training, right? So here there are different you can say data. One is your training data, one is your validation data, one is your testing data. So you have to kind of segregate your number of the data you have with respect to your training sample, validation sample, and testing sample. And again, for validation, there are different type of data pattern. Let's say it is a kind of the time series data. let's say it is your, can see your, kind of your speech data, or can say your, image data, video data. So different types of data are text data. So based on the data, we need to focus on that, what type of validation need to carry out, so that your model will be well validated, and then you can go for some sample testing, right? This is a very big common practice everywhere. Every time people are doing, developing the AI system or AI model, or you can say the AI algorithms. And then finally, we're going to check the performance metrics. When it is, the model is already, there are three phases, I can say three phases. Normally, one is your evaluation. Whenever trying to develop a training pipeline, similarly, we need to develop that your evaluation pipeline, also your inference pipeline. So whenever you are going to check the evaluation pipeline, that means you are evaluating the model performance based on some metrics. So based on some metrics, you are evaluating the model performance. So I mentioned here the supervised learning. Let's say if it is for classification problem, again the two kind of your metrics considered. One is your computation metrics and there is your ROC. So there are very common things I am saying, that for classification people are using for computation metrics or ROC. If it is metrics, computation metrics, again accuracy, precision, recall, F1 score. If it is also ROC, we are saying it is again called a type of area under curve, AUC. So there are different techniques, classification type problems. Nowadays, it is a very standard. I am saying people are different techniques applying to adopt in these scenarios to evaluate your model performance. If it is your regression problem, this is called people are using these again the mean absolute error, mean square error, and coefficient determination error. These are the same kind of the pattern people are using every time, the how to evaluate your model performance. Maybe any deep learning model or any any AI based model. Coming to this AI impact. So this is all about, already we discussed all about that AI at computing, and initial phase of discussion we discussed about that AI at glance. Again, we will discuss in this context of the slides will be AI impact on autonomous driving system, or you can say the ADAS system. So how, as I mentioned that topic title is impact of AI on computation and perception system, and perception in ADAS system. So we all discuss about the computation part, little bit on that part. Also discuss a little bit on that AI, how in very high level. Now we will discuss the impact of AI on ADAS system. If you look these the discussions of impact of AI ADAS system, we need to know, first of all, to understand what is ADAS system, what type of system it is actually. Is it the same system? Now we are that using, let's say for any particular car. Let's say you have a car, there is no ADAS enable, there is no AI enable. Is it the same system? We are going to use the AI system, AI impact on that ADAS in that vehicle, or something different? If different, what type of the AI, you can say the directions of AI is implemented inside this ADAS system? If you look at that, this is a very kind of clear picture. The source I have copied from internet. If you look that AI ML evolution in ADAS, everybody knows that if you look the middle car, let's say it is your ego vehicle. As I mentioned, that ego vehicle means is AI enabled vehicle. We can say the autonomous driving system, where the other surrounding vehicles are the standard vehicle, although we can say the other vehicles around this ego vehicle. And there are, as I mentioned, that there are different types of agents you may visualize in the road, or you can you can face in the road during driving. Either it is a kind of a static object, or it's a kind of your dynamic object. So different pattern, different data, you can say heterogeneity of data by nature, heterogeneity of the pattern, and heterogeneity of also computation. We cannot say single computation. There are different processing unit. So lot of things to be do in that ADAS system if it is AI enabled, right? So in that context, I just thought to bring some important point over here. How data coming to picture, how data playing a very important role in this AI/ML evolution of ADAS, and then how the machine interpretation, because based on this data, based on your training, model training, based on the process development, how the machine is going to interpret, that is more important. So in this picture, altogether, it is a very, you can say the comprehensive, the compact of this all together, data mining, or you can say data analysis, then you can say the training, model training, then you can say the process development, then finally you can say the machine interpretation or machine decision. So where AI/ML is very, very important on these ADAS scenarios. If it is a ADAS enabled, if it is AI enabled system. What is the concept of autonomous driving? Before I come forward these autonomous driving levels, I thought to show you. Look at this right hand side. The particular, it is, I think, is a Qualcomm board utilized ADAS system. There are three windows. First window, front camera perception. Let me pause over here. We look at this front, the particular window here. The first window mentioned here front camera perception. Then second window is your in-cabin view. The third window is your 360-degree surround perception. So there are different perceptions, different senses. I'll explain, one by one, next slides. Just give you the very, high-level insights on that whenever you're talking about this ADAS system have different types of levels, right? If you look at this ADAS system levels, if you look at this, the ADAS level, the level 0, then the level of, you can say the level of autonomy means the level of ADAS, like it is L0, you can say level 0, then level 1, then level 2, level 3, level 4, and level 5. So we are expecting the level 5 means is a fully automation. Coming to level 0, that is a kind of your warning or indication, right? That means what? Hands on, eyes on, the driver is responsible for anything. That is not at all called the ADAS, right? This is a kind of a traditional vehicle. If driver is responsible for anything, there is no at all called the ADAS system, right? I believe it is not at all ADAS system. Similarly, for the level 1, this is called assisted system. Either the control of either in long or the latitude, particular driving, steering, we can say it is a kind of altogether assisted system, right? Similarly, for the L2, which is a partial automation system, and for this kind of, or can say L3, see, people are saying also L2 plus. People are saying L3 plus. Sometimes people are saying L3 or L3 plus. There are different types of, the features coming to picture. That's what based on the particular, the features, people are saying either it is a kind of your, L2 plus or L3 plus. But normally, if it is your L2, we are saying it is a partial automation. And if it is your L3, we are saying it's a conditional automation. And if you look at L4, this is a kind of your high automation. And finally, the L5 will be your complete or fully automation. Where you have looked this particular L3, right? L3 means hands off, eyes off. As I mentioned that in L2, L1, and L0, that is hands on and eyes on driver side. And in L3, hands off on, eyes off on driver side. And or you can say temporarily driver is still responsible in L3, but in L4 and L5 is a complete automation, hands off, minds off. Also in the L5, brain off, also driver off. This is a kind of highly automated autonomous driving system. So altogether you can say two varieties of this autonomous system, maybe based on the features, based on the autonomy. That is called the either it is a either assisted driving, or you can say fully automated driving system, right? So based on that, there are different players in market right now. They are working very closely with this the particular the domain, autonomous driving system. If you look this the video, see what is the the front camera perception. Let's say you are mounting one camera is mounted on your ego vehicle, ADAS ego vehicle, on the camera windshield, means front side of the camera, your vehicle. Then you have to do the perception on your front side of the car. That means on front road of the car, where there are different types of, as I mentioned clearly in the previous slides, different types of objects, or you can say the road entities, along with some kind of your road lane or drivable area segmentation, or segmented drivable area, right? So these things are coming to picture, and because of this, front camera is mounted on the vehicle front, or you can windshield area of the ego vehicle. And then second, let's say you think that second thing, that there are surround view. Surround view means what? As you think that there are, let's say, imagine that there are four camera. One is your rear facing camera, one is your front facing camera, one is your left facing camera, and right facing camera, right? There are kind of your these two mirror. Let's say two mirror. In two mirror, there are two left mirror is a left facing camera, left view. Right mirror, right view. Front camera, front view. Rear camera, rear view, or you can say back view. If you mount the four different camera, we can say the surround view camera, then we can say it is a 360-degree surround perception. And we cannot say this is only for camera. You also you can use your there are different sensors, maybe radar, maybe your lidar, maybe radar, maybe camera. Again, camera, two types camera. Let's say it is kind of your thermal camera. There are also RGB sensor camera. Then IMU, GPS. There are different sensors you may mount. But to make it so less complexity, make it less complex system, we are normally the ADAS practices that the particular ADAS the companies, they are trying to develop the system which is purely camera based. That means less cost, less computation, and it is very accurate decision. That's what people are the entire trend right now towards the camera based perception, rather to make it a kind of a fusion based perception. Fusion based means what? Like let's say lidar data, camera data, radar data, IMU data, coming to the particular, the multitasking of this network or the model, and the fusion data can be fused with respect to their particular features, and then decision taken by the ego vehicle at that moment based on the fusion data pattern. So this is the kind of practice people followed earlier, but in current trend, people are using right now very less complex system, which is purely either on only one single camera, or let's say based on your 2 or 3 cameras, right? Rather to avoid the lidar, rather to avoid that your radar, because it's a costly. Second, that computationally high, because if you look at this complex system, we can say the fusion system, the lot of the particular sensor related to mount in the ego vehicle and to process this data in real time is very, very difficult to compute at real time. Either it is a kind of your edge based computation, or we can say cloud based computation. Maybe maybe you can let's say compute the data is in cloud or in your ego vehicle device itself. You can say edge computation, ADAS SoC itself, right? That's what I'm saying. That the current trend in the ADAS companies, they are looking for this less complex the system, which is maybe a kind of purely camera based system. Have a look on that videos. Three cabin, sorry, three window. First window front camera, second window in cabin camera, cabin view. The third window is a round perception. Okay. Coming to next slide. So if you look at these ADAS verticals, I have shown some video, the previous slide. I explained the particular ADAS autonomy, or you can say the level of autonomy in ADAS system, starting from L0 to L5. Now our focus will be, actually, if you look at the internal aspect of ADAS, how many pillars in the ADAS system? There are actually 5 pillars in any ADAS system. So in any ADAS system, I believe ADAS system is not the level 0 or level 1. At least level L2 plus, it's ADAS system. Because where the driver, that means will kind of hands free, eyes free. That means is not responsible for anything, right? If responsible anything, then of course this is a kind of your again non-ADAS system, or you can traditional vehicle, right, where the driver has to be alert always, right? So to look at this on that context, you can say the driver, if it is a kind of hands free and eyes free, then it is at least called L2 plus ADAS level of autonomy. Where the ADAS pillars internally, ADAS system internally are 5 category. One is your data engineering and orchestration, or you can say data engineering and management. Second one is your sensor and perception system. Third one is your embedded software engineering, and then simulation and validation. And the last one is your functional safety and cyber security. So these all are, is a very, very important aspect of this ADAS system. If anybody has to know, there is a strong team of every pillar of the ADAS. If you look at this ADAS system only to focus on only single pillar, data engineering orchestration, this is very vast area of research. You can do a lot of things on that particular engineering, data engineering orchestration, or you can say data management part in nowadays for ADAS system. So I just double-checked some of the points over here, like vehicle data collection and in-vehicle storage. So if you look at those data engineering and orchestration, so that you can say vehicle data collection, semi-automated automation, then you can say secured storage management, then you can say the data lake building, big data and cloud services. So these are the particular data engineering orchestrations, some kind of the very high level context of this ADAS pillar. Then coming to sensor and perception, I'll explain each one of them, how AI is going to impact of each ADAS pillar in our coming slides. I'm giving just very high level thing on in this slide. What is the data engineering orchestration? What is perception and sensor system? So in sensor perception system, that sensor subsystem development, we can develop in subsystem. Then we can say camera, radar, sensor fusion, perception algorithm development. So these are the particular activities you can we can realize in this ADAS pillar. Then third one is your embedded software engineering. That means platform software development, model-based design and development, AutoSAR and device driver development, then control algorithm development, algorithm performance improvement. So these are the kind of activities we can say combined together inside this ADAS pillar. Then fourth one is your testing and validation, or you can simulation. That means testing infrastructure, test infrastructure setup, design, development, and installation. Then there is a hardware in loop testing, model in loop testing, software in loop testing, functional testing, unit testing, and integration testing. A lot of testings are there in that simulation and validation pipeline of ADAS. And last part of ADAS is your functional safety and cyber security. Well, in that it is a very kind of, you can say the trend nowadays, not only for the ADAS system, anywhere you can go nowadays, functional safety and cyber security is very, very important aspect of this any AI based system, right? So if you look at that safety plan, then hazard analysis, risk analysis, then failure mode of effect analysis, FMEA, then FTA. Then you can say FTA means fault tree analysis. So these are the important aspect of the functional safety and cyber security, where we have some kind of standard safety rule, standard safety norms, we have some kind of standard safety protocols. So these are the the actions people are considering for ADAS system also. So if you combine these all entire pillars, so this is a complete ADAS system, or you can say the ADAS vertical. And if you look at the next slide, ADAS feature, as I mentioned previous slide, in ADAS there are different types of autonomy. Similarly, there are different types of ADAS functions. Or ADAS functions based on the feature states. So again, the feature states, I already mentioned that in our AI and computation, what is the feature, what is the instance, and here we'll focus on that feature state. There are two types of feature. Normally, we are using in ADAS system. One is your autonomous parking feature, and there is autonomous driving feature. So I'll explain the driving features in some use case with these use cases in our coming slides. Also in the parking features, nowadays we are trying to, like the ADAS autonomous driving, also we are working on the direction of the research on a particular area, that is autonomous parking. Suppose you are trying to park your vehicle automatically without human being interference, right? So that is a kind of a model you can train. The pattern we are going to use, a pattern we are going to train the the AI system. So the model, your car is already AI enabled. Based on that, the pattern, based on your parking pattern, it is going to park your carrier, particular car. First of all, it is going to find the pre slots for parking. There are different things. Maybe it is a kind of auto park valet. Maybe it is a kind of auto parking assistant, memory parking, and surround parking. There are different type of parking, autonomous parking system. Maybe parallel parking, horizontal parking, and then we can say triangle parking, vertical parking. Different types of parking techniques are there. So based on that, I have considered that 4 type of high level category, like surround view, memory parking, auto parking assistant, and auto park valet. Similarly, in autonomous driving functions, there are different types of autonomy. As I mentioned that is an L0, L2, or you can say L1, L2, L3, L4, 5. I mentioned here L1, L2, L3, L4, L5. If it is L1, I'm saying it is a driver assistance system. If it is L2, it is a kind of a partial driving automation system. If it is L3, conditional driving, then it is L4, high level automation, and finally it is a fully automation system in L5. Here, if you look that ADAS system, what is the ADAS system? How it looks like that? Look here, the left hand side, the particular the car, where the car is as I mentioned that AI enabled. Of course, AI enabled, and how the AI algorithms are integrated in this vehicle in the particular with respect to the sensor data. If you look the ADAS system, which is a kind of data driven algorithms, and if you look at this the very sample picture of this ADAS vehicle, there are different type of sensors mounted in different positions of the vehicle: camera sensor, radar sensor, lidar sensor. And because the objective is that based on your sensing, based on your computation, based on your actuation, the vehicle will take the decision, right? So if you look at the picture, I just explain over here a little bit through this kind of diagram, that in sensing, of course, in real time, the car is going to that accumulate some kind of data to the sensor. Either it is a kind of your camera sensor, lidar sensor, IMU, your radar sensor, GPS, different sensors are there. And then as I mentioned that there are 2 types of computation. Either the computation is going to happen in your edge device or your fog device. Fog device means it's a kind of a cloud computation. If it is your edge device, of course it is your kind of your ADAS SoC computation. Means there is a kind of your sandbox which is installed inside your ADAS vehicle. And sandbox, nothing but the kind of your, you can say, the embedded hardware already in that box inside, and all the AI enabled AI algorithms, it is deployed inside that particular embedded hardware. And based on that particular computation, and the actuation system will be active at states because of this particular planning. Maybe it is a kind of kind of your motion, maybe kind of your mission, and also prediction. Then the decisions can taken either intelligently or in the straightforward way. So this is a kind of very high level this the picture I have considered from the internet, try to put over here ADAS system, and how the system is altogether interlinked between the sensing, computing, and actuation and decision. And then what are the actual features in this, the scope of for driving? People may do some kind of, the research or any kind of the area, and then they can also explore if it is a driving feature scope. If you look that, so adaptive cruise control, there are different type of features, driving features, maybe sometimes called basic features, sometimes called standard features, sometimes called prime features. If you look this kind of your driving features, if it is a basic feature, we can say the adaptive cruise control, and then we can say adaptive cruise control with steering assistant, emergency braking assistant. A couple of basic features are there. Also, couple of here standard features are there. Couple of the prime features are there. So I don't want to explain these each features. So I request all participants, please go through these particular slides if I share with these participants. And if you're really interested to work together, or anyone interested to explore many things, they can also ping me. Also, they can also share their queries. They can also share their the research interest. So we think in the direction, because it's very open thing to all of us, that nobody can challenge that this is already solved problem, and nobody can think that there is no scope at all to do further research in this driving feature of ADAS. There are a lot of scope nowadays. We are struggling, even the industry is struggling to get accurate solutions for these features to integrate in the AI perspective in ego vehicle. And here the parking feature scope, as I mentioned, like the driving, again there are three type of parking features, maybe a basic parking, standard parking, and prime parking features. The very, very important part over here, ADAS V cycle. Before we explain the ADAS internal things, internal ADAS pillars in details, I thought to explain ADAS V cycle. So if you look at ADAS V cycle, there are 7 states. First stage is your vehicle architecture definition, then domain feature definition, then system definition, then driving applications altogether, then system pre-integration, or you can say the ADAS system integration, then vehicle integration, finally vehicle validation. So these are the particular V cycle. We are normally following any standard ADAS vehicle, and also on top of that, it's a very common kind of your common segment or common type of your you can say the feature or action which is going to integrate in every ADAS system. We call that functional safety, cyber security, and cloud. So cloud, I cannot say it's a common cloud. Maybe sometimes you may also avoid the cloud computation. You will simply focus on the edge computation, or you can say that your vehicle itself compute your data if it is required to compute the real-time things. Depends upon your data, depends upon your hardware. But functional safety, cyber security, it is a very important aspect of this ADAS V cycle, which is common to every ADAS section, or you can say the perception stack, decision stack. And if you look at the very interesting part is the V2X, vehicle to world, vehicle to the other world. So if you look at the vehicle to other world, so the particular communication wise means ADAS have the different type of states, like your sensing stage, computation stage, perception stage, actuation stage, and decision stage. And every stage there is a kind of you can say either you are going to follow some standard functional safety protocols or some standard safety norms, maybe ISO some 2001, something is there, or you can say follow some kind of a SOTIF, functional safety standard. So there are a lot of things to follow for every ADAS stage. That's what functional safety is, a common phase for every ADAS pillar. So if you look at data management, I mentioned data management over here, data collection, data center, data storage, annotation, data analytics. Similarly also for like for this architecture, because before we develop the ADAS system, we need to follow the V cycle, because first of all you need to design or to develop ADAS architecture based on the architecture. Architecture means there are again two type of architecture. Either it is very end-to-end system architecture, where V-cycle is very mandatory to to consider as a kind of reference. Again, if it is going to develop a separate architecture for software architecture, or you can say the perception architecture, then that is mostly for a network base. So what type of network going to use in the perception? Either it is single task network, is a multitask network. So based on this particular the idea and this the requirement, we can develop this ADAS system. And I thought to bring one by one the ADAS pillar. One is your, as I mentioned in the previous slide, that there is a 5 pillar of ADAS verticals. One is your data engineering orchestration. I thought give some of the impact how AI is going to giving a high level impact on this the architecture, right? Sorry, the data engineering and orchestration. So this is the intention behind this data orchestration engineering on the slide. How AI is going to impact. You look here, there are different stages like mass data production, data-driven algorithm, closed loop automation. Rather to bring this explanation, I'll give some insight on that. This stage actually of ADAS is very crucial for data pipeline. Why? If you look at this, the responsibilities of the data acquisition and pre-processing and managing, so the AI can impact in several ways. Let's say data integration and transformation. So if you look at the let's say you assume that data collected from the sensor fleet using because the sensors mounted in the ADAS vehicle itself already. There are different sensors I mentioned, that maybe the camera sensor, LiDAR sensor, radar sensor, IMU sensor, also GPS sensor. So these sensors are already mounted in the camera itself. Let's say data collected, and then what are the actions, or what are the scope on this particular ADAS pillar? Data pipeline optimization, or you can say automated data governance and compliance, then predictive maintenance and monitoring, and then dynamic resource allocation. These are the real important aspect of this data engineering and orchestration. So, and also AI is going to put a one very high level impact on this data collection, data engineering and orchestration, or data management aspect of the ADAS, right? And coming to next slide, data management and cloud platform. Though I mentioned that is your the FDP theme is that AI and cloud computing theory, practice and applications. I thought to bring some of the how the cloud platform is very important nowadays in this ADAS data management perspective, right? If you look at the data sensor, kind of the data coming from the sensor fleet, then the important part is here, either you need to store the data, either it is offline or you store data in online, right? Before that, you need to do some kind of process, you need to follow some process like ingestion from sensor machine and user generated. So again, that passing to second phase, analytics, you can say pre-processing, and then third part, your hot data production cluster with hot storage, and then cold data, older data stored. You can say the cold storage, right? So hot data and cold data. So again, I mentioned here the GPU server and GPUs, because so the GPUs are in maybe let's say it's a kind of a cloud-based GPU. So your cloud system. So there are different clouds, maybe Google Cloud, Microsoft Cloud, IBM Cloud, or Amazon Cloud. There are different clouds are there. So this is a kind of your dedicated cloud particular service you need to need to enable, or need to, you can say, subscribe, and based on that your data coming to that particular phase of the cloud, right? So for that data management system, data management overally, how it is coming to picture in cloud platform. And then look at this ADAS data lake building. I thought to bring this autonomous driving data lake building, because the intention behind this getting this picture from internet, because though your that the thematic area of this FDP is that is AI in cloud computing. So though I am not that particular cloud computing part very high level in that, I can put very high level, not in details, because my talk will be in the perception and that computation. So I'll give some kind of how the cloud is going to be playing a the very pivotal role nowadays in ADAS system. Look the data, autonomous driving data lake. If you look at this diagram, though it is not clearly visible of this, the left hand side part, but if you look at the right hand side part, 10 steps I mentioned. Like there are 10 steps focused to develop a ADAS data lake building. So let's say Amazon outpost of third party hardware processor raw data from the autonomous fleet or sensor fleet for validation or quality checking. So then ingest the vehicle telemetry data to near real time using any particular cloud, right? Amazon cloud, any cloud. It is Amazon, the picture taken from Amazon. That's what I've given this kind of Amazon example. And then remove and transform the low quality data. Then schedule a managed extract from the transformed load. You can say ETL process. And similarly, the process to follow. Finally, that we are going to provide an advanced analytics and visualization tool chain, including the search function for particular scenario using Amazon AppSync or Amazon QuickSight, like that. So this is not that kind of the particular process we are following whenever developing any ADAS system. That is a choice. Either you go for this ADAS data like building through cloud platform, or you may go for this edge platform. That is that is your based on your customer requirement, based upon your particular project requirement, based upon your the resource utilization. Everything that depends upon your the requirement. And then ADAS data transformation. So please stop me if any particular queries in between. I didn't see the screen. I have already shared the full screen. Anybody having the particular queries or doubts, please stop me in between. Is it okay? Shall we proceed? Okay. Fine. So if you look at this, ADAS data transformation, again that autonomous system, autonomous vehicle system, there are data collection centers, maybe data lake, then streaming analytics, AI clustered, then backup and warehouse, and then you can say the autonomous vehicle sensor fleet. So so if you look at this data transformation, how the picture itself explains how the process flow is maintained in this cloud-based data transformation. So let's say you are example that your in-vehicle storage, either the data coming from sensor plate, either you want to store the in-vehicle storage or in-vehicle processor. That is your choice. As I mentioned in the previous slide, the two options you have, either you can do the computation and the perception itself by the edge device, or you can say the ego vehicle in itself, or the cloud device, or you can say the fog computing. If it is going for this edge device, then we need to store data is in vehicle storage and also in vehicle processor computation. But if you're going for this cloud storage or cloud processing, of course there is some kind of phase to follow, like data lake, like streaming analytics, AI cluster, and backup and warehouse. So there are different tools, different techniques, different players, different platforms are there in that. The different kinds of the features, a different service are there in the cloud side. So there is a the unified fast file object center data storage, unstructured data, then also object data is stored in the S3 bucket, and finally and there is a kind of deep learning environment because of the particular data storage, data computation, then called for perception. For perception, of course there is an algorithm required. Let's say algorithm is a kind of your deep learning environment, and then there is a certain the testing environment already enabled in that part. After certain testing environment, the model is well trained for the decision for the perception. So this is called that kind of your ADAS data transformation system. So either you can go for this in vehicle storage, or you can go for this the cloud storage. And now I'll come into the ADAS AI perception. In AI perception, I could quickly cover these slides because there are remaining slides are there. Only half an hour remaining in our hand. In this AI perception, as I mentioned, that what is the requirement for perception in ADAS? I mentioned that situational awareness in ADAS. Situational awareness in ADAS means what? Very high level, you can think that sense, think, and act, or you can say react. What is the sense? Sense the surround view, or the environment of ego vehicle. What to think? Make decisions based on the environment. Then what to act or react? Carry out the decisions. This is called the kind of your situational awareness in ADAS. So commonly known as the perception. And how the ego vehicle sense the environment around it. Where is it located with respect to the other in the environment? Then sensors, cameras, LiDAR. So there are different type of sensors are there in engaging in this particular situational awareness in ADAS. Then a huge volume of data coming to picture in this the perception system of the ADAS. Then use the mathematical model, or you can say the machine intelligence for data evaluation and interpretation. And then now the very common thing here, the perception algorithm development workflow. Actually, what is the the perception algorithm development workflow? If you look that perception algorithm development workflow that I mentioned over here, the perception means that perception means it is the kind of your situational awareness called perception. And if you look at that, you're developing an algorithm, AI level algorithm for this situational awareness of perception, the development. So what are the phases? What are the stages to follow? Like like data acquisition and ingest, data processing and analytics, data labeling, map development, model and algorithm development, simulation and validation, finally orchestration and deployment. This is the common phase we are following for any kind of the ADAS or any AI based perception system. And then there are the different kind of the sub phase like data collection and storage, data annotation and labeling, then regressive test suite, then training data for reference model, then testing and validation, and finally model deployment and optimization and embedded side. This is the kind of actuation. So either it is first of all perception, then decision, then actuation. So these three is very important part for any AI based perception system, mostly in the ADAS system. And then sensor and perception, again the same thing I mentioned that previous slide. What type of sensors, what type of perceive and localize, what type of abstract, what type of plan, and what type of control, and how is AI is going to impact in this perception and sensor perception system. It's very end-to-end system. I explained that from sensor to control. And then this is one very high level example I'm giving here, that let's say this is a kind of use case I'm sharing with you, that let's say this is a in-cabin camera sensing system. The camera is integrated camera inside the vehicle in cabin, or inside the camera inside the vehicle itself, suppose. And if you look this, that first that is a two thing. One is any particular OEM application for camera hardware calibration, that is called intrinsic and extrinsic online. Then the camera hardware like is used for control and calibration applications. Then also image serializer, lens control, video control, then illumination control. There are the different type of the camera control unit. So this is the camera control unit controller. If you look system service, so I do not want to explain each part very in details. Just I'm explaining this kind of high level system service side, and this is the kind of your dialog service, and then memory service, then communication service. So these are the you can say the section where the camera module, or you can say the camera calibration is very much required for any camera based perception system. right? I don't want to explain what is intrinsic camera calibration, what is extrinsic. There is a different detection of research. I don't want to bring that topic in this discussion, particularly in this forum. So this is a very I just try to explain here what are the complex drivers, what is hardware abstractions required, what type of IO drivers required, what type of communication driver required, what type of memory drivers required, what type of microcontroller drivers required. This is again that kind of internal section of this camera control unit software architecture. Similarly, for ADAS blade, ADAS, as I mentioned, ADAS blade means you can say it is kind of your sandbox. So ADAS blade means it's kind of a scalable software platform for functions, feature, integrating supported by several operating system. Maybe you can say AutoSAR and adaptive AutoSAR. Then you can say AGL based, Linux based, like OS. And the perception task is deployed on one or two cores of the ADAS blade. Important part is the perception stack, right? So this is the kind of example of NVIDIA driver work PDA compatible. That are given some kind of a reference over here. I don't want to also explain that part. The performance processor, including the GPUs over here. Just like to give some insights how the ASIL B, ASIL A, and what type of the the AutoSAR adaptive platform is used. What type of AutoSAR the classic platform is used, and how the hypervisor is going to picturize these all the AutoSAR platforms. So and that is a hypervisor support available the different by the third party, and also you can say there are different players in this altogether. We cannot say this is only one in NVIDIA driver work. So there are different we can say the players or the vendors working in this area. And then you can say the multi-core system utilization for perception algo in ADAS blade. So here, if you look this, the horizontal deployment of functions, adaptive AutoSAR based, and the computing layer, real-time sensor and actuation layer. I don't want to explain that what is the computation based on these adaptive and AutoSAR based, because it is again different thing of these ADAS. I just want to highlight the perception stack over here. That perception stack in the sense that the particular information layer of the vehicle API, which is going to connect with your ADAS the particular ADAS bus, or you can say the vehicle bus. So where the real actuation happening, because whenever any decision taken, let's say the computation is the computation happen, after that the decision is taken, but the actuation is going to be happen by this vehicle itself through the vehicle app, or you can say the by the that vehicle bus, right? This is called the that vehicle basic services or information layer. And then another part is the communication handshake between the camera control unit and ADAS blade. So I given some also say some example camera control unit, how the ADAS blade is communicated through this CAN bus of this ADAS vehicle. This is as I explained, ADAS blade means a kind of ADAS SoC, and then CCU means camera control unit. That this is a kind of internal system of this camera control unit, and then this is the internal system of the ADAS SoC, or you can say the sandbox, and there is a kind of vehicle odometry, which is a very important aspect of this the communication handshake between the CCU and the ADAS blade. Again, there is a kind of some perception on road. I thought to bring these examples for the participants. So if you look at the top, the above these videos, where is the raw input, the scenario 1, scenario recorded, scenario 2, scenario 3. Scenario 1 means this is a kind of your front camera. Scenario 2 means a side camera. Scenario 3, it is your traffic camera. You look at this traffic camera, look at the perception side, the last 3. You can say, you can check those, the last 3 videos also. If you look at the last 3 videos, or you can say second row videos. So here, all the perception happening through these, the AI based algorithm. So this is called inference video outputs. I just try to show some example how it is complex system. How, see, if you look at this every inference video, so all the objects on the road detected very clear, very carefully by this algorithm, because before any particular decisions, that is depend upon your perception, how accurately you can percept, then you can accordingly take the decisions by the vehicle. Either it is a kind of surround view, or your front view, or it is a kind of your rear view through the camera system. And then why it is required the data augmentation for perception algorithm? So as I mentioned that it is a clearly called data-driven world, data-driven AI system. So let's say the data is insufficient. Data is insufficient, and you are not going to do any particular data collection further steps to follow, or there is no option to go to the again the recordings to start again based on the scenario wise, right? So that's why, to avoid such particular process, very time consuming process, we can adopt some the image processing techniques called image data augmentation. So again, you can say there are two types of augmentation techniques which will give you the more accurate the decisions, more accurate the KPI, or you can simply improvise your model performance because of this kind of different shape, different rotation, different angle of this your input sample, or you can say the training sample. So which is called the different techniques applied. Either it's your wrap technique, or you can say oversampling technique. If it is again the wrap technique, you can say the kernel filters, or you can say geometric transformations, then random erasing, or you can say it is a kind of your image mixing and color or space transformation. And if it is your oversampling technique, either it may be a kind of your adversarial training, neural style transfer, or GAN data augmentation. And finally, this is sometimes also called kind of called meta learning. That means neural augmentation, auto augmentation, and smart augmentation. There are different techniques are there. If it is called geometrical transformation, people are following clipping, then cropping, rotation, translation, noise ingestion. There are different techniques people are following. You cannot say this is a kind of it's kind of standard I'm saying, but you can also search in Google. You can find n number of geometric transformations nowadays, right? So like you can say cutout, cut in, you can say that mosaic, different techniques people are following. This is not that kind of only the so-called, that they are the so-called or kind of traditional augmentation technique normally people following if any AI/ML algo development pipeline. And for the perception and algo optimization, if you look this part, computational bottleneck, memory bottleneck, because these are two very high level bottleneck in perception, where the algorithm need to optimize, and where the tight coupled techniques are following algorithm techniques. Then where the hardware processor architecture techniques, because of the network structure, because of your fault tolerance, because of your network sparsity, the algorithms and the processor architecture techniques to be optimized in terms of your neural network with resource bottlenecks. Otherwise, you cannot say this is a perception algorithm which is very optimized one, which will give you the more more accurate results, or which will give you the more accurate performance, right? And then embedded software engineering, as I mentioned, this is your third ADAS pillar, embedded software engineering. So where you assume that model is optimized, model is well trained, and you can say the model is best fit to a particular sample data. And now we are going to deploy the model in terms of a ONX file in the hardware side. Hardware side in the sense, whenever you're trying to do some kind of decisions, or you run the algorithms in your embedded side, that is called your model deployment in ADAS SoC. This is your third pillar of the ADAS, called embedded software engineering. In that particular part, you're simply your deep learning frameworks need to be again to be that try to profiling based upon your ADAS embedded the particular core. Either you can say it is 8 tops or 2 tops, particular architecture following in the ADAS associated embedded side. Then you can profiling the trained model, or you can say the deep learning or AI ML model for this kind of the processor to or to decision making wise to check that how much it is fit to take decisions in real time. In terms of your, you can say the Gmax, in terms of your KPI, in terms of your FPS, in terms of your overall bandwidth. This is the very important aspect of this ADAS pillar. Coming to the simulation and validation, again the same thing that AI is how AI is impacting simulation and validation part. As you know that these are the particular tools people are using. Again, the tools are developed using some kind of the particular model, and the model nowadays maybe utilized, maybe developed using this AI techniques. We can say that this is a software in loop, or you can say hardware in loop, or you can say on road testing or vehicle in loop. There are different techniques, integration testing. So there are different techniques that people are following. But my point is that how AI is going to impact in the simulation and validation testing side of the ADAS. Because of these models, or because of the simulation validation, there are different tools are altogether integrated, and the tools are nothing but some kind of your application, and that is developed using certain AI ML algorithms. If you really want to work on this the directions of this validation simulation aspect of ADAS using impact of AI, it will be kind of revolutionary change in this market. So nobody can that think on that part how it will be a very fruitful when it is a impact of AI involved in this kind of particular testing and simulation of ADAS features. Then functional safety and cyber security. Functional safety and security in the sense, as I mentioned, there is a final section of this in ADAS pillar. Like as I mentioned, how it is important for this particular ADAS real time wise. You know that the safety plan, hazard analysis and risk analysis, and the failure mode and effect analysis, we can say FMEA. Then that is, you can say the reliability aspect of this the ADAS features or ADAS functions, and then failure analysis. So these are the most important part of this ADAS. My point to bring over here, how AI is going to impacting this functional safety and cyber security. If you look this 6 layer of security around the park, inside the park, building, engine rooms, modules, then racks, so everywhere. So if you look at the 6 layer of the security, like level 0, level 1, 2, 3, 4, 5, 6. So outside the campus, on campus. So I'm not going to bring these things to particular ADAS scenario wise. I'm thinking there is a overall, I'm saying physical security, data security. If you look at this storage case, the party case, and that can say the that the shipper trust manager, and then you can say the transport encryption. So there are different types of functions altogether playing that the functional safety side of the ADAS. Now the final section of this discussion, that how AI is going to impact of AI on the ADAS use cases. There are several use cases in this AI impact, or you can say use of the AI algorithms in these ADAS use cases. If you look one by one, I will not cover very few things. I have encapsulated in this discussion. If you look at this adaptive use control, just look this video. if you look at adaptive cruise control, this particular ADAS, use case, this is comes in L2 plus level of autonomy, and through this feature, vehicle can automatically adjust the speed of ego vehicle with respect to the front vehicles, and it actually enhances the both convenience and safety by maintaining a safe distance from the front vehicle. And we can say sensor detection, that is also radar or camera within this detect system of the vehicle ahead on the road, and also speed setting, and also object selection and automatically speed adjustment. So these are the particular tasks performing in the adaptive cruise control altogether, and this is a very high level feature on the ADAS side, and this is called the L2 feature. As I mentioned, there are different ADAS autonomy level of autonomy. We can say L2 plus, L2 and L3, L4, L5. This is called L2 plus feature. It is a very standard feature in ADAS side. I think nowadays every vehicle having the kind of very all the SUV segment, XUV segment having this particular the SEC feature in their vehicle itself. So next will be your parking slot detection. If you look at this parking slot detection, so nowadays there are different parking, autonomous parking, realizing in your vehicle type, like you can say the type of parking maneuver, like you can say angle parking, parallel parking. I already mentioned a couple of slides, in the previous slide, that where I mentioned the real parking features, the types of parking features, autonomous parking features, where you can say angle parking, perpendicular parking, back parking, then parallel parking. So, and you can say that autonomous system side having the different parking algorithms already deployed in nowadays in the ADAS vehicles. So if you really want to work on these detections, so there are a lot of scope pending. Right now you can check that how best utilize these the research exposure towards the autonomous parking only, not driving. Driving itself is a separate part of separate doing of the ADAS. Also parking is a separate doing of the ADAS. So if you look at only focus on parking, also this is a very vast area to explore nowadays. And then types of parking slots, like if you look at this picture, the different parking slots are by based on these angle parking, perpendicular parking, with back parking and parallel parking, different slots are available. Just example I'm giving over here. And similarly, another use case is that object detection in ADAS. As I mentioned clearly, there are two types of object visible in the ADAS, on the road. Either it is a kind of static entity, or we can say the dynamic entity. If it's static entity, you can say the road lane, the road curve, or the road boundary. You can say the road line, and if it is also traffic system, traffic light, traffic symbol, they are static objects. And if it is you can say it is the dynamic object, like other eco vehicle. Also your the pedestrians or the road users, and then you can say the animals, very visible in every Indian roads, actually animals very frequently, and that is called object detection in ADAS system. So I don't want to explain these background objective benefits. So this is a kind of use case. So I just given about the sample example. Let's say you can use any standard detection algorithm. Let's say you can use any normal CNN. Let's say LOV5 is very famous nowadays, which is a Coco data set trend model, LOV5, where the backbone is CSP DataNet. So and if you look at this, I'm not saying that in details, just I'm saying if you want to focus also these use cases in very in depth, and if you look at these requirements, all use cases might be give you more mileage to do the research and also explore the area in terms of your computation, in terms of your algo development, in terms of your perception, also in terms of your the particular data side, and in terms of your simulation, and also all together in cloud platform. You can say cloud-based perception. So this is only not that only kind of one use case. Use case may be extended to different directions of your ADAS and based of your platform. Another use case also right now, the VRU detection. VRU means vulnerable road user, that detection, and intention prediction. If you look at this particular picture here, our focus is to detect the pedestrian, or you can say the vulnerable road user, and how can though they are very frequently maybe come in front of your ADAS eco vehicle on road. So before happen any hazardous situation, any accidental situation, how eco vehicle can take a safety measure, by looking their intentions. How to take the intentions? Because there is a kind of key joints or skeleton present in the every pedestrian, that may be 21 key joints, sometimes called 18 key joints. Sometimes some algorithms, they are taking care of the 23 key joints. Based on the key joints, that means key joints pattern, the ADAS, the algorithm, algorithm can take a decision, can estimate the intention or the action of the pedestrian, which can save your eco vehicle for a comfortable driving, or you can say safety driving. That is the intention behind this ADAS use case called VRU detection, or you can say the pedestrian detection and intention prediction in ADAS scenarios. Then this is all together for the object detection, drivable area segmentation, and lane line detection. In this object detection, drivable area segmentation, and lane detection, like this is again I am saying the previous use case, it was only object detection, but here all together you can mix this algorithm. This is you can say the hybrid algorithm, where this is the efficient net backbone is the efficient net B3, and here the neck is define module based on the efficient det, and again you can say the detection head is here yellow beeper, and the segmentation head is called the hybrid. So that's what I'm saying hybrid. Why? Because of the detection and segmentation both coming to picture in single AI algorithm. You look at the algorithm, look at this output of this algorithm. Here the every road objects are detected, whether it is a kind of static object or dynamic object, along with your road lane segmentation. We can say drivable area segmentation. So these are the drivable area in between the road lines. This is called one kind of algorithm, A algorithm, which is kind of hybrid algorithm, both for the both detection, drivable area segmentation. And then again, that is a kind of your sensor fusion based perception. Like as I mentioned, that there might be some scenarios where let's say in the night scenarios, let's see the day scenarios where the camera is unable to detect some of the the road objects, right? The road, you can say the particular path planning during the ADAS driving, ADAS scenario. So that time, let's say you are using both sensor data. One is your LiDAR sensor data, one is RGB sensor data. If you try to fuse the the particular feature level fusion and try to develop the AI algorithm, and with respect to some particular KPI, or in terms of some the FPS, the frame per second, if you want to develop some algorithms, also there are number of data sets available nowadays, and there are number of data set, n number of algorithms available. Just I'm given a very high level over here, that if you can realize that things in your coming if you're really interested for that coming research considered into your the future. So if you look that particular aspect, the perception is not only happening through the camera system. Perception may be happen for the LiDAR system itself and also fusion system itself. The fusion means you can going to fuse the camera data along with the LiDAR data. So mostly the camera data is in your kind of your RGB format, video format, and the LiDAR data, it is your point cloud. You can say 3D point cloud data. In LiDAR, 3D point cloud data are in different nature, and in camera is RGB data. It is kind of a different nature. So if you are going to mix it as a feature fusion, we can say heterogeneous fusion of the particular data by nature, and trying to develop certain algorithms which is going to do the real perception in real time for this fusion of the features. And very interesting part is here in-cabin sensing system for safety. As I mentioned that there are different use cases also for ADAS. Maybe either it is a kind of a front camera, front view, or surround view, or in-cabin view. If it is in-cabin view, that is called in-cabin sensing system for safety. So in-cabin means, of course, there are two type of in-cabin the agents. One is your driver, and there is your kind of your pilot or co-pilot. Then the occupant means the kind of your can say the what type of the occupant it is, either it is a kind of a passenger or it is a non-passenger. So that is up to the that ADAS system in cabin. But the intention is that these are the important sensors people are using nowadays for the in-cabin sensing system. Either it is a RGB sensor or it is a radar sensor, it is a IR sensor. IR means infrared sensor, it is a thermal sensor. Look at these three pictures, right hand side. This is your detection of the through detection of the occupants or the passengers detection through your thermal sensor, and this is your your radar sensor. This is your camera sensor. So these are the sometimes you can also use one fusion system for the in-cabin, or sometimes you can use a single modality of the in-cabin sensing system. So this is again high level in-cabin integration. I don't want to explain that part. If you look at the in-cabin sensing basic scope, so in-cabin also there are different type of the functions you can realize through driver or through occupant. Maybe driver detection, head pose estimation, eye state estimation, viewing direction, object detection, facial landmark detection, many more. I have not gathered all these all in particular slide. And also advanced scope. Any particular person, if you really want to extend this in-cabin sensing system advanced scope, there is no at all any solution available in market. Top companies are struggling to integrate these solutions in their ADAS vehicle in terms of your the driver health monitoring, driver damage detection system, and driver action recognition system, which is the advanced part of the perception algorithm, which need to be built for the particular feature set, which is demanded by these almost all the nowadays the ADAS OEMs, maybe Mercedes-Benz, BMW, Volkswagen. They are looking for this kind of solutions, how to integrate these things into in your ADAS vehicle. And coming to the next slide, this is your driver damage detection system. Again, it's a very high level. Again, I'm saying that this is I'm giving just one example of the driver damage detection. We look at these the features we considered over here. Like one is your eye aspect ratio of the driver, then one is your head pose angle of the driver, then mouth aspect ratio of the driver. Based on these particular feature set, we develop one one particular transfer learning based algorithm, which is going to give you the driver state classification, either you are active or drowsy during driving. And this is again the basic scope details. As I mentioned, that the different perception layer, computation layer, and decision making layer, and finally the action layer. As it is a kind of action means either it is going to give you a warning to driver through HMI, or it is a kind of action planning through actuator. This is the basic scope. This is the advanced scope. A lot of things to to explore if you're interested for this background of this in-cabin sensing system for ADAS vehicles. And this is all about my discussion so far. This is one slide I kept intentionally to ask the audience, what is your view in the entire discussions we have come across on the 2 hours almost. What is your view by looking these directions of the ADAS AI in ADAS? What will be the future of the AI in terms of ADAS?